What is the linear approximation of 63.8 using f of x equals square root of x with x equals 64? Okay, so the idea here is, so we'll draw, this will be x, this will be y, which is the same as f of x, and we will draw f of x, which is the square root of x. Looks something kind of like this probably, and maybe a little bit more exaggerated. So it's going up forever, but it gets less and less steep. And maybe one more try. There we go. That's good enough. And so the idea here is, this is the square root of 64 is 8. And so we have this point here. But, and this goes over to, no, there we go, 64, and this goes to 8. And it's telling us that, hey, we're not at 64 here, we're instead at 63.8. And it's like using a tangent line from here, find this value right there. And we could go through the whole formal tangent line process and plug in the values, but just kind of using an understanding of what's going on logically, we can probably do it a little bit quicker. So I'm going to start by going through the tangent line, finding the tangent line for this. So we'd say y equals x to the 1/2. Okay, f of x. F prime of x equals, what is this? 1/2 x to the negative 1/2, which is 1 over 2 square root of x. And therefore, when we're looking, the slope for our tangent line would be f prime of 64. Since we're going to use the tangent line at 64, because it's easy for us to calculate the square root of 64, but it's hard for us to calculate the square root of 63.8. So this would be 1 over 2 times the square root of 64, which equals 1 over 2 times 8, which is 16. 1 over 16. Yep, and it's basically saying that that slope of that line is 1/16. So then we do y minus y1 equals mx minus x1. This is just the slope of this is the equation for a line if you know the slope and then 2 points, an x point and a y point. I guess that's just 1 point, isn't it? One pair of coordinates, a pair of numbers. Okay, so then we know that y equals x equals 63 point. Nope, x equals 64 and y equals 8. So y minus 8 equals 1/16 times x minus 64? 64. And let's see here. Y equals x over 16 minus, what's 64 divided by 16? I think it's 4. So 64 divided by 16. Yeah, it's going to be 4. Because it's, yes. 64 divided by 16 is 4. Minus 4 plus 8. That turns into plus 4. So we have x over 16 plus 4. And that is the equation of our tangent line. And we can use that to find what y of 63.8 would be. So it would be f of 63.8 would equal 63.8 over 16 plus 4. And going over to Wolfram, I know you can't use Wolfram on the AP exam, but it's a small calculation. I'm sure you can figure it out on the calculator. 7.98, and then rounding to 3, it would be 7.988. 7.988. And so it'd be this answer right here. So that's how you do it with the tangent line. And that's a good method of doing things. But it's a little bit more formal than we probably actually have to be here. So one thing we could think of is f of 63.8 equals f of 64 minus delta x times dy dx. So what we're saying here is if we have this point right here, which is f of 64, we have this point right here, which is the function of 63.8, and we're going to subtract from that some value of, we're trying to subtract off some value of y here. This is a delta y. And so if we have delta x times dy dx, you can be like, all right, this dx in the bottom is kind of like a delta x. And so when you cancel that out, this kind of is sort of like f of 64, nope, that's terrible, minus dx, dx delta y, cancel, and you're left with that delta y there. And so the way we're going to do this then is we're still going to find the derivative, so dy dx. So dy dx would be the derivative with respect to x of x to the 1/2, right here, and that gives us 1/2 x to the negative 1/2. And so we know for this we're going to use 64 because we know how to find the derivative at 64. This is the point we're using. And then our delta x here, we can calculate that out. That's just 64 minus 63.8, which is 0.2. I'm good with that, 0.2, or 1/5. So this would be function of 64, which is 8, minus 1/5 times, we plug in 64 into our f prime of x here, which is 1 over 2 square root of x, is 1 over 16. Okay. So if we multiply this out a little bit, we get 8 minus 1 over 80. 5 times 16 is 80. I think so. Yes. Divide by 2, add the 0. And so if we put this into our Wolfram alpha, 8 minus 1 over 80, we get the same answer, 7.988. I rounded 3 decimal places. 7.988. So this would also give us 7.988. Right here. So this is referred to generally as like Euler's method, I believe. And so the idea with what we did right here was we have 2 points, one y point, y value that we don't know. We have a y value that we do know and is relatively easy to find. And then we use the derivative to kind of find the slope of this tangent line. And then we multiply it by our x. So one way to think of this is you have your f of, I'll call this y1, equals f of some y initial, minus delta x, the x difference between the two, times dy, I'll call this dy0, over dx. And this is the derivative at your known point. And this is kind of the Euler's method, allows you to kind of step along and find different values. So in the grand scheme of things, this is the same thing as taking a tangent line, but it's usually a little bit quicker, and for me, more intuitive to use Euler's method. And that's how you find the answer of 7.988 as a linear approximation here.